Okay, so tomorrow's performance final will have 4 questions, kind of like an extended response type deal, and you pick 2 of them. Geez, today's review has 4 questions. Weird. That's a coinky dink. Also before I forget, I was told to inform you that this Saturday from 10 to 2, they're having a math boot camp to prepare kids for finals. So if anybody wants to show up, it'll be in both in this room and the one next door. It'll be Algebra 1, Algebra 2, and Geometry. That'll be here. So there's no sign up or anything. You just show up. 10 to 2. Practice for finals. All right, so number 1, solve one of the following systems of equations by substitution and one by elimination, and explain why you chose the method. So let's just solve both of them. Which one would you pick for the first one? Yeah, I would also. Why elimination? What would be a good justification if you're going to explain why you chose it? What did I give you as good rationale for using elimination? You want a clue? It starts with standard and ends with form. Yeah, because they're both in standard form. If you want to go a step further, it's because the y's have matching coefficients. They both have a 1 in front and different signs. So you would say elimination works beautifully because you can already eliminate the y's. When we eliminate, what operation are we really doing? It's elimination by. I can see we've all been working on the final review. I guess nobody's been studying. Elimination by addition. So you have to add in every column. -4 plus 2 is -2x. 26 plus -16 is 10. Divide by -2. So all the children rejoice because x was -5. After you solve for one variable, you should be able to solve for the other one. I know there's going to be one solution here. Plug that -5 for either of the x's. Because the y on top had because I'm looking for y, it has a positive in front, I would probably recommend that one to you, but it's not because you have to. So, but I would say -4 times -5 plus y is equal to 26. So 20 plus y is equal to 26 minus 20 minus 20, y equals 20. If you're asked to write this as an ordered pair, 20, oops, sorry, y is 6, sorry. If you're asked to write this as an ordered pair, the solution here is -5, -6. And even though I didn't write a narrative, you will have space to write a narrative. And what are some of the key points? I'm not gonna grade you based on grammar. Some of you that are, a little bit weaker with the English language, I'm not gonna be too big on spelling or anything like that. It's not an English class. Okay, but there are gonna be certain key things I'm looking for. So if you were to get something like this, what are some of those key words I just told you I'd be looking for? Yeah, that both equations are in standard form. You definitely want to mention that. What else? Well, yeah, but that's already implied that we're doing it by addition. The y's have matching coefficients, but different signs, meaning that they're ready to be eliminated. You can eliminate them on the first step already. For the second one, therefore, I would then use substitution. Why would I want to use substitution here? The y is already isolated. So if the top y is equal to x minus 11, that means we're only interested in when the bottom y is equal to x minus 11. So I can get this bottom y, take out the bottom y, and replace it with x minus 11. If you remember, even though it seems like an eternity ago, when we learned to do systems of equations, whether you're doing elimination or substitution, when you first eliminate or substitute, what do both of those steps have in common? Even though you're doing it a different way, what are we gaining by substituting or eliminating? Or better yet, what are we losing by substituting or eliminating? Yes, correct. We're going from 2 variables to 1. But because we only have 1 variable left, we can distribute, combine, add. 6x is equal to 36. And then the kids are getting excited because x is equal to 6. Now, unlike with elimination, look, well, like elimination, when I go to solve for the second variable, I can use whichever equation I want. But unlike elimination, there's always going to be elimination. Sometimes like, flip a coin, whatever, who cares? Pick whichever one you want. There's always going to be one here that's to your advantage, because if I have x, what am I looking for? I'm looking for y, and what's different about this y than the other y? It's already isolated, so I'm always going to want to go with the isolated one, because then I don't have to cancel anything else. Just y equals 6 minus 11. My fingers tell me that that's negative 5. So then my solution, if I were to write it as an ordered pair, alphabetical order, 6, negative 5. Is this record already? Yes? Question? Syria? No? Irma? Yes, so? Y is isolated, so it's ready to be substituted. Honestly, that's basically it. There's not much. You don't need much more to read it. You know, for substitution, as long as it doesn't have to be y, it just has to be a variable. So if any variable is isolated already, I would do substitution. Okay, so backwards. Define. Oh no, it's not. No, it's not. No, it's not. Okay. So what I'm getting from this question is that it's not saying to define the domain and range of any one specific function. They're just saying to define domain and range generally. Like, what is domain? You could, well, you could, the key is that you say the word set. Domain is the set of all x's, or you could say inputs in a function. And actually, no, even better than that, because technically we don't need to say function. Let's say a better word, or a more general word, is in a relation. Because you don't need to pass a function test in order to have a domain. What do you think range would be? Yeah, the set of all y's or outputs in a relation. Anytime you have, this is what you learned right before you got to me. Anytime you have two variables, it's called a relation. But if that relation happens to pass a function test, then you can also call it a function. Every function is a relation. It's just not every relation is a function. You have to pass a function test. Complete the table with ordered pairs that would represent a function. Okay, so if I were to have a table that would pass a function test, what do they teach you not to do? So it's a little bit of an oversimplification, but my understanding is that even in middle school they taught it to you this way. Yes? Yeah, don't repeat the x's, exactly. And since you're not, unless you're giving something specific, like they're not telling you that it needs to be a linear function or a quadratic function, because in that case, you might have to like square the y's or something like. Real simple. If you're given this general of instructions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. Don't get complicated. Or even better, look, watch, even better than this. Let's stick to single digits. Let's do this. 0, 1, 2, 3, 4, all positives, because I'm given complete autonomy to do whatever I want. Yeah, sure, why? Yeah, 0 is a number 2. And really, if you wanted to even like show off, when I have a 0 as an input, what is that ordered pair doubling as? What else is that represented? Which intercept? The y-intercept, yeah. So here you go. We just gave the explanation. Explain why the table of values you created in the function. The better way to explain it is that each input has a unique New York. Ow, now, brown cow. The arsonists had oddly shaped feet. IQUE. Each input has a unique output. You've never seen Anchorman before?
Oh wait, yeah, I have.
You've never seen it.
I remember on the tour and their bus flips and that guy has like the lobster. Yes, I've seen the movie. I have the movie.
Identify the domain and range of the function you created. Okay, so here we go. I created this. Now, is this function is it discrete or is it continuous? Yeah, discrete. If it's just points, it's discrete. When it's continuous is when you see it like written as an equation, where like it would all connect. These are just 5 points, but what are the points on the domain? 0, 1, 2, 3, and 4. What's El Rango? 5, 6, 7, 8, and 1. 2, 3, 4, 5. Thanks, Hope. Isaac didn't find it humorous at all. You're lost on this, Adrian? No. Don't trip. Ah, hey, something more familiar. We just went over this side. Use the function below to answer the question. And let's first graph it and then fill in the following. Jamin, this is supposed to be less distractions over here. Hope, quit being so interested. Stop it. All right, what form is this function in? Standard, yes. So this is ABC. Not that you have to, but if you want to show off, you can even try answering the stuff in B before you even graph. Do I already know if it's going to open up or down? Why up? Because this is quadratic. What's the domain going to be? Todos los números verdaderos. It means all real numbers. The range we don't know yet because what do we need in order for the range? Yeah, we need a vertex. We don't have that yet. Same thing for axis symmetry. Do we know the y-intercept? Yeah, it's going to be at 0, 30. You're going to be x equals something. Yeah, it is going to be x equals something. But we don't know what. We got to find the vertex. So what's the formula for the vertex? Negative b, which is going to be negative 16 over 2 times a. That's going to give me negative 4. I forgot the negative, sorry. I said it right. I said it right by then. Then it's catching on like a fever because I saw on this last test that you'll get back on Friday. This synthetic substitution. Everybody's doing it. Everybody's substituting synthetically, so let's do that. If I plug in a negative 4 and then A, B, C, drop the 2 as if it was hot, multiply times negative 4, negative 8. Leslie loves to do 16 minus 8, which gives her 8. Then times negative 4 again. Then subtracting a negative dose. So where is L vertexal going to be at? Okay, negative 4, negative 2. Ergo, vis-a-vis concordantly, what's the range going to be? If I know that this is going up, here, better yet, let's do it this way. If you go back on the videos, I'm sure it was I just kind of squeezed it in there, but you may have heard me mention, when you hear maximum or minimum, what are they talking about? We're talking about the vertex. The word maximum or minimum applies to vertex. But technically speaking, most of the time when they use that verbiage instead of vertex, they're really just talking about the y. So if they wanted to know, like, what is Or in this case, is this going to have a maximum or a minimum if it's going up? It's going to be a minimum. So I'm going to put a min. Oops. But if they wanted to know where that min would be, what's the lowest that this is going to go? If we're talking about the y, it's -2. The minimum value is -2. And it looks like the way that like they only wanted to know maximum or minimum, but I'm just trying to help you with the range. So if the lowest that this is going to go is -2, where are all the y's going to be? What's going to be that set of all y's? If the lowest I go is -2, I cannot go lower than -2. I can go greater than or equal to -2, or you don't have to. It's like you guys just write what's on the board, but I do not think about what I am writing. I just write it. I wrote the same thing but two different ways. You don't have to write both. If you want to write that, cool, good. But if you prefer set notation, which interval notation, which a lot of you just completely botched up, then you can also write this as -2 to positive infinity. One or the other, but you don't need both. And then yes, now we know our axis of symmetry is going to be at x equals what? X equals what? -4. Okay, so now we're going to plot. We know our vertex is at -4, -2. But oh man, I can't fit my y-intercept here. It's too big. Yeah, Papa, we're really taught you to get 1, 1, and 2, 4, and use these as a set of directions, but then just count it from the vertex. I showed you how to use a formula, but that required too much studying and memorization, so I just said, all right, keep the x, but then get the y and multiply it times a. What was a? So 1 times 2, which is going to be 1, 2. And then keep the x, and then go 4 times a, which is 2, so that's going to be 2, 8. But think of these as a set of directions, not as a point. I'm not going to plot a point at 1, 2. I'm not going to plot a point at 2, 8. I'm going to use the axis of symmetry. That goes through the vertex. And I'm going to say, all right, from the vertex, I'm going to go 1 to the right and 2 up. Put a point, and then flip the script. Then I'm going to go to my next point and say, all right, from the vertex, not from anything else, from the vertex, 2 to the right and 8 up. And again, flip it. And all the children rejoice because they have their parabola. The parabola came and saved the day. Yeah. On the notes, I gave you these as starting points because 1 squared is 1 and 2 squared is 4. So then all you gotta do is get the y's. The 2 and the 1 and the 4, and multiply it times a. 1 times 2 is 2. Well, 4 times 2 is 8, and then you can count that from the vertex. Even though you weren't here, did you watch any of the videos that I posted online that would have made it almost as if you were here? Huh? Solve the 2 quadratic equations below. You must solve one using quadratic formula and the other using factoring. Okay. Okay. Let's approach this a smart way. If you look at the 2, which one do you think factoring would be preferred, or actually required, basically? Raise your hand if you think the first one. Raise your hand if you think the second one. And the rest of you are going to reserve judgment. You got to do the first one, factoring. Because remember, factoring is when we do, see, both of these require ABC. They're both equal to 0, which is good. 1, 1, negative 6, 1, negative 3, negative 5. See, the problem with the second one, if you're going to do factoring, you need to look for two numbers that multiply to negative 5 and add up to negative 3. It doesn't exist. What are the only numbers that multiply to give you 5? 1 and 5. And even making one of them negative, you're never going to add up to negative 3. So the only thing that would work for this one is quadratic formula. So that means the first one you're going to have to factor. Can you think of two numbers that multiply to negative 6 and add up to positive 1? Negative 2, positive 3. So x minus 2 and x plus 3 is equal to 0. Zero product property says you can now make each one equal to 0. Sorry, I'm going kind of fast. It's just I want to be able to finish. X can be positive 2 and x can be negative 3. Negative 2. For the next one, though, I plug it into quadratic formula. So x is equal to negative b. If b is negative 3, then we got to put positive 3 plus or minus the square root of. Negative 3 squared minus 4. A is 1, c is negative 5 over 2 times 1. Yes. Equation or expression? There's an equal sign, it's an equation. So it's equal to 0. So just all I did on the right side was I left it equal to 0. All the factoring occurred on the left side. If it's an expression, if there's no equal sign, then the directions are going to just state a fact. Here it says to solve. The first word says solve. Okay, so positive 3, and that's important. Some of you guys still made that mistake. Positive 9. How many negatives come after the square? 2. So plus 4 times 1 times 5 is 20 over 2. The nice thing here, what's 20 plus 9? That's positive. So how many solutions would you get? 2 solutions, but it's also prime. So you cannot do the square root. There's nothing outside that can be divided, so it would just stay like that. That is the solution. Yeah.
Take out the 9.
Take out the 9.
Yeah.
9 plus 20, yeah, but if you're going to take anything out, it has to be multiplication. So 29 is prime. You can't just take out a number just to take it out. It's gotta. Any question? I know I went kind of fast, but it's the best we could do today. So remember, tomorrow you'll have 4 questions. You pick 2 also, and I'm going to leave this on the video. If you go to the e-class page, maybe for the first time this year, listen, I still got a couple of minutes. Watch. And you go to content and week 18, which I showed you yesterday. Not only do you have the final review, which is due Sunday, and we talked about it, but look, I also added this take-home quiz that I told you. If I know it's a lot of work, but if you choose to do it, it'll replace your lowest quiz grade of the semester. Okay, and that one I'm going to give you until the night before your final, second period test on Tuesday. So you would have until Monday night to do this, next Monday. You guys test second block of on Tuesday. You also have the this final, the practice test that you took yesterday. You have your actual percent and then the adjusted percent on the curve. Look through it. As long as you register the score, you can do it 2 more times. I'll give you for this one until Sunday also, because I can't review this until Friday. So I'll give you until Sunday. If I have a score for you already, you can do it twice. If I don't have a score for you, either because of absences or for whatever reason, I don't know where your head was at, then you can only do it once. Also by Sunday.
You said there was like some math help.